Okay, so we're going to continue this problem that we just finished on limiting reactants when we had a reaction of ethylene, a combustion reaction of ethylene, and we determined that oxygen gas was our limiting reactant. Okay, so we're going to continue this exact same problem, but now we're going to take the problem one more step further, and we're going to find what's the mass of the excess reactant. Okay, our excess reactant. So since we know that oxygen gas, or O2, is our limiting reactant, we know that there's going to be some ethylene left over, okay, because the oxygen is going to get used up, but the ethylene is not. Okay, there's going to be some leftover of that. So that's going to be our goal this time, is to compare our limiting reactant to our excess reactant, and we're going to be able to determine how much of that is left over. And we're going to, again, do that with a T-chart. Okay, so we already found that the limiting reactant was O2. Which would mean that our excess, or our leftover reactant, would be ethylene, C2H4. Okay? That's what you solved during the last problem. So now we want to find the mass of the excess reactant. We know we started with 4.95 grams of that reactant, but we want to find out how much was left over. So we're going to go back to look at our limiting reactant. And we know our limiting reactant was oxygen, and we started with 3.25 grams of oxygen. So we're going to go back to a T-chart here, and we're going to start with what we know, 3.25 grams of O2. And we want to compare the quantities. If we used up all 3.25 grams of oxygen, we want to compare how many grams of ethylene that would use up. So we are going to do a comparison between grams of oxygen and grams of ethylene to see how much of that ethylene would get used up if we use up all 3.25 grams of O2. Okay? So we're going to continue our T-chart here. We'll go grams of O2 on the bottom is in 1 mole of O2. Since it's O2, we know this is going to be 32 grams. To cancel moles of O2 needs to go on the bottom, and moles of C2H4, or ethylene, goes on top. This is our mole ratio step. So in this step, we need to look back at our balanced chemical formula, so hopefully you still have that in your notes, to look at the coefficients before these two reactants. Okay, if you look back at your balanced chemical formula, we should have a 3 here and a 1 here. Okay, our mole ratio is 3 to 1 oxygen. Okay, then we want to cancel moles of C2H4 and go to grams of C2H4. Okay, 1 mole is equal to how many grams? We found the molar mass of C2H4 before, and we got 28. Okay, so now we've canceled grams of O2, we've canceled moles of O2, we've canceled moles of ethylene, and we're left with grams of ethylene. So what this is telling us is that if we use up all 3.25 grams of oxygen, which we know happens in the reaction since this is our limiting reactant, it's going to tell us how many grams of C2H4 are also being used. Okay, so now let's go ahead and multiply across the whole top, divide by the whole bottom. And I got 0.948 grams. Okay, 0.948 grams. So again, what this tells us is that since we used up all 3.25 grams of oxygen, we used 0.948 grams of ethylene. We used that much. But we started with 4.95 grams of ethylene. So if we want to find the excess, or the leftover, excess is another word for leftover. If we want to find how much ethylene is left over, we need to take our starting amount, 4.95 grams, minus 0.948 grams. Which gives us, let me kind of move this out of the way, which gives us about 4.002 grams, or 4 grams of excess ethylene. Okay, so again, what we did here was we compared our limiting reactant, which is O2. We compared our limiting reactant to our other reactant, or our excess reactant. Okay, and we were able to find the mass of our excess. Since we compared these two values, this gives us the amount of ethylene that was used during the reaction. So we're going to take our starting amount minus the amount that was used up in the reaction, and that's going to give us our leftover, or our excess. So these problems, we did a T-chart to find, we did two T-charts to find our limiting reactant. We did another T-chart to find the mass of the excess. Okay, there's lots of different things, lots of different steps we have to go through to be able to answer all parts of this question. So as you start working through the problems, make sure that you're paying attention to what exactly the question is asking for. If it's asking for a specific product, make sure that you're doing your T-chart to that specific product. If it's asking to look at the excess reactants, that means you're doing a T-chart between your two reactants, from your limiting reactant to your excess reactant. All right, we're going to try another one here to do some more practice with finding excess reactant. So go ahead and get this written down. Our equation is not yet balanced, so that's important to understand. It's not yet balanced. We need to balance that equation first. Okay, so let's go ahead and see what our balanced chemical equation is. Hopefully you've done this yourself already. We need a 2 here. We have 2 ions on the left, 2 ions on the right. Right now we have 3 oxygens on the right and 2 on the left, which means we need to double this. Now we have 6 oxygens here, 6 oxygens here, and we need to fix our iron to now be a 4. Okay, so we should read 4 irons, 3 oxygen, and 2 iron oxide molecules. 4 irons on the left, 4 irons on the right, 6 oxygens on the left, and 6 oxygens on the right. Okay, so this should be our good balanced equation. If you would like to go ahead and start this problem and work it by yourself to see if you can do it on your own, that's great. Go ahead and hit pause now and start doing that. Otherwise, I'm going to work it through the whole way through. Okay, so we're going to start with 45 grams of iron and 87 grams of oxygen gas. Remember that whenever we start with two amounts of our reactants, we've got to do our T-chart twice. The first question that we're going to answer is limiting reactant. So first question we're going to answer is what's the limiting reactant, which means we need to do 2 T-charts, one from 45 grams of iron and one with 87 grams of oxygen gas. Okay, we only have one product, so we don't have to pick which product we're going to compare to. But let's go ahead and start with our 45 grams of iron. We want to go from grams of iron to moles of iron. Molar mass of iron is 55.85. We want to go from moles of iron to moles of our product. And this is the step where we look at our balanced chemical formula to find our mole ratio. So mole ratio of iron is 4 and mole ratio of iron oxide is 2. Okay, so those numbers came directly from the coefficients in our balanced chemical formula. Lastly, we're going to go from moles of iron oxide to grams of iron oxide. And we need to find our molar mass to go here. And I got about 159.7. Okay, somewhere in that range. Could be a little different depending on rounding, but that's pretty close to what we want. Okay, so now we've gotten rid of grams of iron, we've gotten rid of moles of iron oxide, and we're left with grams of iron oxide. Okay, so we multiply across the whole top, divide by the whole bottom. Okay, and I got a value of about 64.34 grams of iron oxide. Okay, so that tells us that if iron were the limiting reactant, if we used up all 45 grams of iron, we would produce an amount 64.34 grams of iron oxide. So let's go ahead and start our T-chart now, going from oxygen gas. So we're starting with 87 grams of O2. I'm going to go from grams of O2 to moles of O2. From moles of O2 to moles of our product. And again, this is the step where we'll look at our mole ratios and look at the coefficients directly from the balanced equation. Okay, and now we're going to multiply across the whole top, divide by the whole bottom, because we've gotten rid of grams of O2, moles of iron oxide, and we're left with grams of iron oxide. And here I got a value of 289.5 grams of Fe2O3. Okay, so we've got two pretty drastically different numbers here. 45 grams of iron will give us a product amount equal to 64.34, and 87 grams of oxygen gas will give us a product of 289.5. Okay, so which of these two reactants is going to be our limiting reactant in this case? Hopefully you can see here that since iron will give us a lesser amount of product, our limiting reactant is iron. Okay, whatever T-chart gives us the smallest amount, we have to look back to the beginning of that T-chart to tell us which reactant is limiting. So here, iron is our limiting reactant. Okay, we can't just circle this number and say this is our limiting reactant because this is a product. Okay, the 64.34 grams, that's the product, that's the amount of product. We've got to look back to the beginning of our T-chart here to show us that iron, in fact, is our limiting reactant. Okay, so we've answered the first part of our question. What's the limiting reactant? It's iron. Okay, so Fe. What's the maximum amount of iron oxide that can be formed? Okay, the maximum amount is going to be the theoretical yield from our limiting reactant T-chart. That means when we use all 45 grams of iron, we're going to get a value of 64.34 grams of iron oxide, and then the reaction will come to a stop. Okay, so the answer to that second question is 64.34 grams. Okay, and now we're going to go ahead and answer our last question. How much excess reactant is left over? So I'm going to get rid of all this work here so I can have some more room. But we've answered the first two questions, and we're going to go about answering the last one. Okay, so we know that iron is our limiting reactant. We can form a total of 64.34 grams. That's our theoretical yield here of iron oxide. But now we want to find out how much oxygen is going to be left over. Okay, so to do that, we're going to compare 45 grams of iron to grams of oxygen. We want to find out how many grams of oxygen are used during the reaction, and we're going to subtract that from our starting amount. Okay, so we're going to go grams of iron to moles of iron. From moles of iron to moles of O2. And here we're going to get our numbers directly from our balanced chemical formula. we'll go moles of O2 to grams of O2. All right, we've gotten rid of grams of iron, moles of O2, and we're left with grams of oxygen. So we're going to take 45 times 3 times 32 and divided by 55.85 divided by 4. And it gives us a value of 19.34 grams used. That's how many grams of O2 are used. Okay, if we use up all 45 grams, we're going to use up 19.34 grams of our oxygen. This, again, this 19.34 is not how much is left over, it's how much is used during the reaction. So to find our excess, or to find our leftover, we're going to take our starting amount of oxygen, which is 87 grams. We're going to subtract out the amount that was used. So we're going to take 87 minus 19.34. And we'll get an excess of 67.66 grams of O2. Excess. Or leftover, or however you want to write it. But we've got 67.66 grams of oxygen gas that is in excess. Okay, so it's very important to remember that when we do this last T-chart, we're comparing our limiting reactant here. Okay, iron is our limiting reactant. We're going to our extra reactant, O2. The amount you get out is the theoretical amount that was used. You subtract that from its original starting amount. That's where the 87 came from. And this is telling us how much oxygen is left over.